Hello everyone, my name is Haidar Hamiyeh and this video is presented by the Cultural Club of the South. This is a quick revision of recursion, which is one of the most important topics coming up in our final exam on Sunday. You can find these previews and these problems in the CCS drive, previous drives, and we will be solving around 2 to 3 problems together. I'm gonna walk you through how to think about recursive problems, how to approach them, how to find a recursive solution, and finally how to write the code. Examples أهين شي بهالموضوع. Okay, let's start. So this is problem 3 and I think spring, the final exam of spring 2023-2024. Let's read the problem. Find all decompositions. Given a positive integer n, we would like to find all possible ways of obtaining n. If starting from the integer 1, we are allowed to repeatedly either add 1 or multiply by 2. Right? So we only allow 2 operations. This will come in hand very shortly. For instance, if n is equal to 5, we have 4 decompositions. 1 plus 2 times 2. Okay, fine. هودي الجمل حيضيعوكم شوي لأنه you would think that for every number you're gonna have to think about all possible combinations وتوجعوا راسكم و overwhelm yourself يعني. Write a function decompositions of n given a positive integer and returns a list consisting of strings corresponding to all possible decompositions of n as explained above, and then blah 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 blah. The hint here is recursion. And what is recursion? Recursion is basically having a problem, say, of size n. The input is n. The recursive approach is to, given the solution of the smaller problem, n minus 1, or anything less than n, for any k less than n, given the solution of this problem, you are able to use it to solve for the bigger problem. And I think this is very intuitive and trivial in this problem. And the only way to show this pattern on how can I use the solution of smaller problems to solve the bigger problem, the only way to find this pattern is to expand. You have a scratch paper in the exam, go ahead and write decompositions 1, 2, 3, 4, 5, and then find a pattern. And the pattern should be found comparing the solution of one problem to the solution of a smaller problem. So let's just do this, okay? First step, Damon, expand. Give yourself some examples, you have time. So let's see decompositions of 1, which is given here. Actually, هون هو يعطينا examples, so it's very handy, right? We have only 1, fine. Decompositions of 2, we have 1 plus 1 and 2 times 1. Decompositions of 3, we have 1 plus 1 plus 1, 1 plus 2 times 1. Decompositions of 4, we have 1 plus 1 plus 1 plus 1, 1 plus 1 plus 2 times 1, blah 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 blah. So let's say وقفنا هون, right? We don't have much time for examples, but enough is enough. What pattern can you notice بالsolution تبع هودا؟ And as I gave you 1, you give me this. If I give you 2, you give me this. 3, this. 4, this. So given 4, شوفي ال 3 how السولوشن تبع 3 وين موجودة بال 4. This is the main question of recursion. So for example, هون بنلاحظ أنه for example لحتى أطلع ال decompositions of 3, I took all the decompositions of 2, right? أحني هون the same ones and I added just 1. Okay. لل decompositions تبع 4, I should be taking كل تبع 3 أحي هون and this one أحي هون and just add 1 to them. But since بهذا البروبلم كمان we can multiply by 2, since 4 is an even number, we know that 2 times 2 is equal to 4. So you can multiply by 2 all the decompositions of 2. And this is very clear here. We have the decompositions of 2. And we just multiplied by 2. لما توصلوا على هيدي المرحلة بالفحص انه you found the pattern, that was the hardest part in recursion. I hope the pattern is clear for you guys, and just to be sure let's try it in 6. Okay, وانا عم حل هلا قدامكم exactly like I would have done it بالفحص. So according to us, according to our pattern, for 6 I should take all the decompositions of 5 وزيد عليهم 1. Okay, so هيدي the first decomposition أحيي هون, we find it and we add it 1. This is the second decomposition, we find it here, we add 1. This is the third decomposition, we find it here, we add 1. This is the fourth decomposition, we find it here and we add 1. But since 6 is an even number, then we can also multiply by 2 all the decompositions of 6 over 2, which is 6. Here's the decomposition of 3, we find it here. This is the decomposition of 3, we find it here. And then we just multiply by 2. And that's how we have decomposition of 6. We're now given the decomposition of 6, we can find the decomposition of 7, the decomposition of 8, وتبع 9, وتبع 10, وتبع 11, وتبع 12, وتبع كل شيء. It's like a domino effect. You have the solution for a problem. Given the certain pattern, you can find the solution to another problem, and so on till infinity. This is the main idea of recursion, and this is how you should think about it بالفحص. So, let's recap. First step, expand. Write down some examples. معك وقت. Write down some examples. Find the pattern between the solution for n-1 and n. أو حتى in this case, بين n-1 و n وبين n over 2 و n. Then we are allowed two operations. دايما find the pattern between solutions. Solution for n-1 and the solution for n. يعني إذا أنا أعطيتك ل n-1 كيف فيك تلاقي لي n؟ This is recursion. After we find the pattern, expanding and blah blah blah. وأكيد يعني expand مش أنه يزبط على 2 3. Once you find the pattern مثل ما عملنا هون للنمبر 6, just apply it for any n وشوف إذا بتزبط. Give yourself some examples. Then step, we should be looking for the base case. وهون it's pretty trivial, or most of the times it's gonna be pretty trivial. Just look for the lowest number of n, وهو usually بيكون عطيك solution. مثلا هون يعطينك إياها decompositions of 1 شو لازم ترد له. And this is the lowest number. وهون قايل لك انه just let me find it. Yeah, n starting from the integer 1. n اصغر شيء فيها تكون هي 1. So ال 1 ما فينا نستعمل شيء قبله لحتى نلاقيه لانه ما في شيء قبله, هو اصغر شيء. بس من ال 1 we can find 2 و 3 و 4 و 5 و everything. The last step is to code. And this is the easiest step in my opinion. هو the hardest step is to find the pattern after expanding to find the pattern. هيدي أصعب step, and this is where students struggle a lot لأنه بيفكروا أنه immediately when you read the problem you have to start coding. و يعني إذا you don't have a pattern in mind that you want to write in code, it's not gonna be very trivial how to write the code. But once you find the pattern, the code part is the easiest part. So I wrote the code and I've put it right here. Okay, and we'll go through it step by step. أهم شيء, do not overwhelm yourself. It's an easy concept with an easy implementation. I'm gonna walk you through the easiest way to implement a recursive function in code. So let's recap شوي. Our recursive pattern here is that given an integer n, first we check if n is even. If it is even, then we call the same function, we get يعني the decomposition of n over 2, which would give us a list containing all of the possible decompositions of n over 2. And then we iterate over this list, and for every one of them we add 2 times and we add the parentheses. هيدي بس for semantics لأنه هو بده parentheses حول 2 times مثل هون مثلا وهون أو هون. Okay. Now if n is not even أو حتى if it is even, يعني بالحالتين we're gonna take the decomposition of n minus 1, we're gonna get a list of decomposition of n minus 1, and then we're gonna add a 1 plus at the beginning. And then we combine these two lists, and we'll have the output for n. Okay, so we have the pattern in mind. We have the base case. For n equal to 1, we're gonna return a list of containing just number 1. Now to write the code, I'm gonna give you a tip that I do not hear in class a lot, maybe بمرقها الدكتور, but it is the best tip when it comes to writing recursive code, and it is very simple. I want you to recall that recursion is very similar to induction. And for those of you who are taking CMPS 211 or not 211, when you want to do a proof by induction, you first prove the base case, then you assume P of k, and you prove P of k plus 1, right? These are the 3 steps in induction. And the thing that is counterintuitive, but it works, and if you really understand induction and how it is very similar to the domino effect, assuming P of k is very hard to digest in your mind, but it works. That's all we care about. You assume for P of k and you prove for P of k plus 1. Now I want you to realize that induction is basically recursion. Recursion basically is reduction in code, right? So let's follow these steps, the same steps. First of all, we have a base case, which in our example would be if n is equal to 1. For the base case, we want to return the list of size 1. And here you can see it very clearly in our code. First step, if n is equal to 1, return the list that contains the integer 1. Next step, which most people forget when they write recursion, is assume P of k. And this means when you call the function itself, just assume that it is giving you the right output. So for example, I have an input of size n, right? To find the solution for n, I'm gonna use the solution for n minus 1 and then do some work here for it to become the solution for n. When I call the function itself on n minus 1, just assume that it is giving me the right output and work on that output. Do not think what happens in the stack, what happens, like how do functions call themselves. Just assume that it is giving you the right output. When in our code, for example, when we call decompose on n minus 1, just assume that you have the correct solution for n minus 1. Now do something with it for it to become for n. And this is how easy it is. It's very trivial. And here to understand the code, we have an output list. This is what we're gonna return at the end of our function, right? And then we are calling decompose on n minus 1, and we assume that it is giving us the right output for n minus 1. So now we have the list of the decomposition of n minus 1. And what we are doing is we are appending to this output list, we are appending for every element here a 1 plus, which is in the pattern that we discovered earlier here, right? You take the decomposition of n minus 1 and then you add plus 1 at the beginning. But the main step here is to assume that this gives you the right output, because it will. If you go back in the recursion stack, you're gonna arrive to the base case, and then the base case is gonna return up to the stack. So just assume you have the correct output and work your way through there. Similarly, here we are checking if n is an even number. We are calling decompose on n over 2. Just assume that this gives you the right output. Just assume that n over 2 actually gives you the correct decompositions of the n over 2 number. And then what do we want to do with it? For it to become the correct output for n, we're just gonna multiply by 2 for each one of these. For xn, you are iterating through it, and then you're adding it 2 times with parentheses, right? And don't get yourself confused with this f here. This just means a formatted string. It's the easiest way to write strings and variables in Python, but I don't think it has been covered in EECE 230. So you can just write it the normal way, like 1 plus, and then concatenate the string x plus, and then just that's it, and then for 2 add the parentheses. Don't get confused by this, right? This is just a string. And finally we are returning the output, and that's it. This is recursion in a nutshell. First step is to expand. Take a pen, take a paper, and start writing out some examples. Find patterns that connect the n-1's output to the n's output. Like, I give you the n-1, how do I get n from it? Once you have the pattern in mind, which we found here, which is +1 or ×2, you're done. You're basically done. You just need to write the code. Just translate your ideas into code. And when translating it into code, as hard as it is, just assume that you're getting the right output for n-1. Now what do you do with it? ما بيهمني أنا قد إيه عم ترجع بالrecursion stack. ما بيهمني إذا like in the recursion stack ما بيهمني كم مرة I'm calling the function وشو عم no. أنت you're here. أنت you just care about this part. Assume this is true and prove this, and you're done. This is induction. This is recursion. This is all of it. This is how easy it is, right? Unfortunately, this video has been given to me on a short notice for me to record. ما قدرت to do a problem that is harder than this. بس ما تقصروا, right? في كتير previews CCS drive, في كتير previews online, ما تقصروا, right? Keep practicing and eventually this will become very natural. When you look at this, don't think like the debugger. ما تعمل لي مثل الديباجر تفوت على decompose على n-1 وتبلش تفكر شو عم بيصير وكيف بوصل لا just assume that it works. ومش كمان تكتبوا لي comment للبروفيسور assume that it works وخلص تمشوا. لا أخي, انتوا assume it works واشتغلوا مع the correct output of n-1. And this is actually correct code. Like, I've tested it and everything. And yeah, that's it. Thank you very much for going through this problem with me, and I'm gonna share my email. If someone has any question, you can email me at this. If you have any question about the video, or actually for any inquiry about this, just email me. هلا مني TA مني شيء, بس انه I'd be very happy to help anyone. Thank you very much guys, and inshallah maybe I'll see you in another video.
اليوم هقدم لكم واحد من recursion problem مارق ببريفيوس موجود على الدرايف CCS. خلينا نبلش نقرا السؤال. We want to write a function that generate all non-decreasing list of n, which given an integer n return a list consisting of all non-decreasing lists whose entries are in the range from 1 till n, and we assume that n greater or equal to 1, and this end here is recursion. أول شي خلينا نطلع على البيس كيس. إذا ال n equal to 1 we should return a list of list which is 1. اوكي, هلا إذا ال n equal to 2 هي ال return value. إذا منلاحظ هيدا ال 1 هو present here و here, وهيدا ال 2 هو ال n, صح؟ نفس الشي إذا منلاحظ هول السب ليست, إذا منفكر بهول السب ليست بال n equal to 2 هن موجودين هون, والزيادة عليهم هن هاي ال 1 مثلا هون, وهيدي كمان موجودة هون, وزيادة عليها هيدا ال 2 هون كمان موجودة هون, زيادة عليها ال 3. سو هولي هون منبلش نلاقي السب بروبلمز. n-1 بتنجاب من ال n-2 وال n-2 بتنجاب من n-3 لنوصل للبيس كيس. هون ببين معنا انه هو recursion problem. تمام. هلا خلينا نفكر كيف ممكن من ال n equal to 2 من n equal to 3 نلاقي جوابها using n equal to 2. اذا n equal to 2 الليست اللي حتردها هي 1 list of list فيها 1 1 2 2 2. تمام. هلا ال 3 شو حتكون؟ هيدي زيادة عليها كل الارقام from 1 till n, واللي هي from 1 till 3, يعني حتكون list of list 1 1 3 1 1 1 sorry 1 1 2 1 1 3 مظبوط. هيدول بيكونوا using هاي زدت I for I in range من 1 ل 3 على الليست، وزدت على الليست الأساسية اللي هي الانسر. نفس الشي هون ال 1 2 ال 1 2 شو حتصير؟ حتصير 1 2، بس ال 1 ما بتزبط معها لأنه ال 1 هي أصغر من 2، سو بدنا نحط 2 بعدين بدنا نحط ال 1 2 3. اوكي نفس الشي لهاي كمان شو حتصير؟ حتصير 2 2 2 لأنه ال 1 ما بتزبط، و 2 2 3 تمام. وشو كمان؟ 2 3 3 و 3 3 3. وهون ما فينا ننسى كمان انه هيدي ال 1 3 فيها تكون كمان 1 1 1 سوري 1 3 3، وهوك هيك وهيدي فيها تكون كمان 1 2 2. سو نحنا هون دايما عم نستعمل n - 1 ونزيد عليها ال n from 1 ال شو اسمه ال I going from 1 to n على اخر. مثل ما بنلاحظ كمان هون ال 1 2 وال 1 2 وال 1 3 هيدي هي هاي، بس هيدي بلس 1. سو دايما لازم نحنا نفكر هون شو السب بروبلم. السب بروبلم هو n - 1، بس هيدي ال n - 1 عم تعطينا all combination، و assume انه بتعطينا all combination لل n - 1. بدنا نزيد عليها تعولات ال n. تمام. كيف فيني نزيد عليهم؟ بدي اعمل for loop اول شي بتمرق من 1 ل n، وبدي سيف اول شي هول الفاليوز لل n - 1. let x سيف مثلا function generate all decomposition of n - 1، وكمان of size k لانه في ال k في يكون كمان of size k، لانه هون اذا بنلاحظ ال 1 2 وال 1 2 3 وال 1 وال 1 1 3 هيدي هول كمان فينا نلاحظون انه هن في إلهم سايز. ليش؟ خلينا ناخد example اذا ال n equal to 2. تمام. هي شو عم بصير؟ عم بكون عندك من ال n equal to 1 عم تردلك 1 1 1 list of 1. هيدي هلا نحنا شو عم بصير لنرد ال 2؟ اول شي عم نحط حد ال 1 1، بعدين 1 2، بعدين 1 3 سوري 1 2، بعدين هيكون عنا 2 2. هدول هي ماشي، بس اخدنا الفاليو للي قبلها لل n - 1 وشو عملنا؟ والكي هو ذاته بعده السايز كي اللي هي سايز equal to 2، بس غيرنا زدنا على الليست element from 1 to n. بدنا كمان نتأكد انه هو element اصغر من اللي اكبر من اللي قبله او equal. سو هون بنلاقي العلاقة بين ال n - 1 وال n، ومن هون بنبلش نكتب الكود تاعولنا. هلا كيف انا افكر كيف بدنا نكتب؟ اول شي البيس كيس دايما. هون البيس كيس شو هي؟ بيس كيس اذا ال k equal to 1 اللي هو ال length لل decomposition او ال list، واذا ال k equal to 1. اذا ال k equal to 1 شو فينا نعمل؟ نحنا بس بدنا نرد list going of size 1. تمام. واللي هي of size 1 sorry length of الليست رح نردها هي 1، بس فيها element 1 2 3 till n. اوكي هي حتكون البيس كيس تاعتنا. هيدا example كيف نقدر نحل هيدا البروبلم. اول شي نحنا عايزين helper function. هاي الهيلبر function حيكون عندها 2 بارامتر k واللي هو length لل non-decreasing list، والان واللي هو اذا بدك الرينج من 1 till n. تمام. هلا هيدي هي البيس كيس تاعولتنا. اذا ال k equal to 1 يعني عندك ال k equal to 1 وعندك ال n. اذا ال n مثلا 3 بدك ترد له 1 2 3 صح. نحنا هيدي كيف فينا نعملها؟ using هيدي الفور لوب. هاي الفور لوب شو بتعمل؟ بتمرق من 1 till n plus 1 لانه n included، بترد لنا list of list فيها الاليمنتس from 1 till n plus 1 till n sorry. اوكي هلا اذا الكي منا 1 شو لازم نعمل؟ لازم نطلع equal to 1. شو لازم نعمل؟ الكي سوري منا equal to 1 شو لازم نعمل؟ لازم نفتش على كل شيء decomposition او list of k of size k minus 1 لحديت ما نوصل للبيس كيس. وعلى هول الليست شو لازم نعمل؟ نمرق عليهم واحد، وهذا اللي عاملينه نحن هون. وليش هون حطينا كمان عم نمرق على ال s of k minus 2 n plus 1؟ لأنه إذا ال k equal to 2 حتكون هيدي s of 0. تمام؟ يعني نحن عم نمرق على الليست. يعني إذا عنا نحن 1، يعني نحن هون بنكون عم نزيد على الليست اللي هن موجودين أصلا بالأكس الاس، واللي هو الاليمنت اللي هو ان اكس اللي نحن اصلا عملنا له جنريت بلس الاي. هلا ليش نحن حطينا اس اوف كي ماينس 2؟ لانه هي البيس كيس كي ايكوال تو 1 ما حيوصل لهون. الكيس ايكوال تو 2 حيكون هيدا اس اوف 0، كي ايكوال تو 3 حيكون هيدا اس اوف 1 and so on. هيدي هي اللي بتخلينا to generate all possible list of non-decreasing list of size k minus 1n. وهون بنكون سيفنا كل الفاليوز بقلب ليست اللي هي y، ونحن بنرد الواي. تمام؟ هلا الواي بكون بقلبها كل الجنريت سايز generate list of non-decreasing element of size n. وهيك بنكون حلينا البروبلم تاعونا. هلا بس اكويك ريكاب او تاوت شو عملنا. اول شي فتشنا على البيس كيس، بعدين لقينا شو الباترن بين n-1 بين n و n-1، بعدين فكرنا كيف ممكن نربط هالباترن بين هول الاثنين، وهيدي اللي كانت هون اللي هي استعمال الرابر فانكشن اللي استعملناها هون لنطلع نطلع all non-decreasing list لل n-1 n of size k-1 مع n مع same n. تمام؟ هلا بعد هيدول الثلاث ستيب شو عملنا implement للفانكشن وجمعت هول الستبس. اكيد كتبنا البيس كيس. فهون نحن دايما باي ريكورجن بروبلم كيف بدنا نفكر؟ بدنا نفكر ببيس كيس، بدنا نطلع بالريليشن بين n و n-1 or مثلا size of k-1 and so on. بعدين بنطلع الباترن بين هول الاثنين. كيف فيني اذا معي n-1 كيف فيني اطلع الان؟ تمام؟ هلا اكيد بأسيوم انه n-1 حترد true، لانه هي بالريكورجن دايما n-1 حترد لك الترو فاليو. بأسيوم انه هي بترد لك true value. بدك تشوف اذا على الان اذا معك جواب n-1 كيف فيك تعدل عليه ليطلع لك جواب n.